Hello, today's lesson is on the graphs of the sine function and the cosine function. Today we're going to be graphing the transformations of the sine and the cosine function. We'll be able to determine the amplitude and the period of these two sinusoidal functions. We're going to be graphing the sinusoidal functions y equals the sine omega x, and we're also going to be able to find an equation for the sinusoidal functions from the graph. We're going to be doing this in several videos, so this will be part 1. Alright, when you first started graphing lines way back in middle school, the first thing that you did was make a table. So we could graph the sine of y equals x by making a table. We know from our previous lessons that the domain of the sine function is any angle from negative infinity to positive infinity. So we can pick any x that we want because our x's here stand for our angles. So we're going to pick some of the angles that come from our unit circle because we know the values of the sine of those angles. So we're going to pick 0, and the sine of 0 is 0. We're going to pick pi over 6 because we know that the sine of pi over 6 is 1/2. We're going to pick pi over 3 because we know that the sine of pi divided by 3 is the square root of 3 divided by 2. We're going to pick pi divided by 2 because we know that the sine of pi divided by 2 is 1. Those are all in the first quadrant, so we need to pick some that are in the second quadrant as well. 5 pi over 6, the sine of 5 pi over 6 is 1/2. Let's pick pi. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. Now what we're doing is we're taking these off of our unit circle, the sine and the angle off of the unit circle. Now what we're going to do is plot these points. Now, I'm going to show you the graph so that you can see the graph, and then we're going to look at it and how we drew this. And whenever I draw the sine graph, the first thing that I want to do is draw my x and my y axis. Scoot that over just a little bit. Okay, here's my x axis, here's my y axis. And the first thing that I'm going to do is graph those points that I just looked at on my table. And hopefully you have got those written down so that you can look at them. The first point was 0, 0. And I'm going to look at the last point, which is 2 pi 0. And I'm going to plot that. Whenever I'm making my x and y axis and I need to make my scale on my x axis, I always look at those x's and I start with 0. And since I know that the period of the sine function is 2 pi, I'm going to go ahead and move over and plot my 2 pi. Then I'm going to take those two places on the x-axis and I'm going to divide them in half. Well, halfway between 0 and 2 pi is pi. Then I'm going to take this interval from 0 to pi and divide it in half. And halfway between 0 and pi is pi over 2. And then I'm going to take the pi and the 2 pi and divide it in half, and halfway between 1 pi and 2 pi is 1 1/2 pi, or 3 pi over 2. So I divide my x-axis into those intervals. Those are my critical intervals. That's one rotation around the unit circle from 0 to 2 pi. Now I know that the maximum value of my sine is 1, and I know that the minimum value of my sine is -1. So I'm going to put those values on my y-axis because that's the range of the sine function from -1 to 1. And now I can just plot my points. So 0, 0, pi over 6, 1/2. It's about right here. Close enough. Pi over 2, 1. 5 pi over 6, 1/2. pi 0. Then I went to 3 pi over 2, negative 1, and 2 pi 0. The 5 critical point, I left off my 7 pi over 6. I apologize. 7 pi over 6 is at negative 1/2. And I left off my 11 pi over 6 at negative 1/2. Then I can just connect to those points in a nice smooth curve. And this is the first rotation around the unit circle. This is 1 period of my sine function. Now the critical points that I need you to be sure you graph are the 0, 0, the pi over 2, 1/2, the pi 0, the 3 pi over 2, negative 1/2, negative 1, I'm sorry, I said that wrong, 3 pi over 2, negative 1, and pi over 2, 0. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. Those are the 5 critical points that I would like for you to learn. I want you to know this function so well that you can graph those 5 critical points and get your sine function at any time. The sine function does not just stop here at pi over 2, and it does not start here at 0, 0. I want you to remember that the sine function, y equals the sine of x, all of its x's can go from negative infinity to infinity. So we're talking about the x's that we're allowed to put into the sine function, which is the domain, is from negative infinity to infinity. All real numbers x can go into the sine function. So that means that this sine function continues to the left and continues to the right. When we graph them in class, when we graph them on a quiz or a test, I'm going to ask for this one interval, and then I'm going to ask you to take that interval and transform it. But I need you to be sure that you understand that this is not where it stops. It continues on to infinity in both directions. Characteristics of the sine function. The domain is the set of all real numbers. Okay, we talked about that. It goes from negative infinity all the way to infinity for our x's. The range consists of all real numbers from negative 1 to 1. Lowest value is negative 1, highest value is 1, inclusive. The sine function is an odd function, which means it has symmetry with the origin. The sine function is periodic with a period of 2 pi. Here's the period of 2 pi. It's periodic, which means that after this first period, it's going to continue in that same pattern. And the x-intercepts are at your integral multiples of pi. So negative 2 pi, 0, negative 2 pi, negative pi, 0, pi, and 2 pi, 3 pi, 4 pi. The y-intercept is at 0. 0, 0 is your y-intercept. The maximum value, 1, this maximum value of 1 is going to repeat. And it's going to occur at negative 3 pi over 2, at pi over 2, at 5 pi over 2, at 9 pi over 2, etc. And the minimum value is negative 1, and it occurs at negative pi over 2, 3 pi over 2, 7 pi over 2, and 11 pi over 2, etc. Now, we can use the graph of y equals the sine of x to sketch any sine function using our transformations that we talked about yesterday. So if I look at the graph of y equals the sine of x minus pi over 4, I hope that what you're going to realize is y equals the sine of x minus pi over 4 is that the argument is x minus pi over 4, which means that we are adding this negative pi over 4 inside the function. Okay, this is inside the function. And anything inside the function affects the function horizontally. Let me scoot that over. It affects the function horizontally. And remember, it always does the opposite of what you would expect it to do because it's x minus pi over 4. So what we're going to be doing with this graph is graphing the sine of x. So it's going to be y equals the sine of x. And we're going to then shift it to the right pi over 4 units. Okay, it's x minus pi over 4 shifts to the right. So we've got here on our slide y equals the sine of x. And then we're going to shift it. Everything, notice everything shifts. Look at 0, 0 and how it shifts over to pi over 4. So if I was going to do that on this graph right here so that you could see it, let's get a different color. Here's pi over 4. Okay, here's pi over 2. Halfway between pi over 2 and pi is 3 pi over 4. Halfway between pi and 3 pi over 2 is 5 pi over 4. And then halfway between 3 pi over 2 and 2 pi is 7 pi over 4. And everything just shifts pi over 4 units. This is going to shift pi over 4 units this way. This is going to shift pi over 4 units this way. This is going to shift pi over 4 units this way. Whoops, too far down. And this one will shift pi over 4 units this way. And that's going to be at 9 pi over 4. And then our graph now will look like this. So we have shifted everything pi over 4 units to the left. I'm sorry, to the right. Too early in the morning. Shifting everything pi over 4 units to the right. Okay? So now if I wanted to take the sine of x and graph y equals the opposite of the sine of x plus 2, I hope you're going to know that the first thing we're going to do is flip. So take a look at this. All we did here was flip the graph. This is a this is a vertical reflection over the x-axis. Okay, notice that because if you look at the critical point pi over 2, 1, and notice that it's now at pi over 2, negative 1, the 3 at pi over 2, negative 1 on the sine of x is now at 3 pi over 2, 1. So we've flipped this over the x-axis. That's a vertical reflection because of the negative on the outside of the sine of x. Now all we have done is move it up 2 units. All right, the next thing we're going to do is talk about the cosine of x, but I'm going to do that in the next video. So you can go to part 2 and take a look at the cosine of x.